Alright, in this set of problems, we're using angle addition to set up some equations and solve for x. Angle addition postulate just tells us that the measure of the small angle here, in this case maybe UTA, plus the measure of this other small angle, ATS, when you add them together, you get the measure of the big angle, UTS, which is just kind of the two parts add up to the whole. So, we're going to use that fact to set up an equation and solve for x. So let's see. We have STU, that's the big angle, is 89x. Hey, there's a radio station. And ATU is 53 degrees. And let's see, STA is 35x plus 1. So now we've got that these two smaller angles, when you take their measures, and their measures are represented by these two expressions. One's just a number, and the other one is a variable expression, has a variable in it. And they together add up to the large angle, which is its measure is represented by this expression here, 89x. And so we're going to use this fact to set up an equation. So we know that 53 degrees plus, that's 35x plus 1. Add those two things together. We should get 89x, the measure of the larger angle. So now we're just going to go ahead and solve this equation. Let's see, I'm going to start by combining like terms. Over here I have 53 and a 1 makes 54. Then I got my 35x. I got 89x over here. I got all my variable terms. My ultimate goal is to get the x by itself, which means we first have to get a single x term. Right now we have two x terms. So we need to take away one of those two. And I think the one I'm going to take away is this 35x. So we're going to subtract 35x from both sides. So that leaves me with 54 over here. We take 35x away from 89, and we have, wasn't this convenient, 54x. Now we've got a single x term, and we're just going to go ahead and divide by the coefficient, 54, in order to get the value of x. Divide both sides by 54. And I get 1 equals x. All right, let's do another one. Next door here. See, we've got a measure of DEV. That's represented by 2x plus 7. And let's see, DEF. That's the big angle, 17x plus 7. And then VEF is 150 degrees. Okay. So to set up our equation now, we have 150 plus 2x plus 7 equals, let's see, 17x plus 7.
Daddy, a good question.
Okay. So first thing I'm going to do is combine like terms over here. I've got 150 and a 7. That gives me 157. Over here, nothing to 17x plus 7. Okay. Let's see, now I want to get all of my variable terms together. I only want to have one variable term. So I need to get rid of one of these. I'll get rid of the 2x. So that's going to leave me with 157 over here. 17x take away 2x is 15x. All right. Now I want to get the variable term all by itself, which means I need to get rid of the 7 over here. I'll get rid of that. Of course, I take 7 away from both sides. Now that I have a single variable term, I just divide by the coefficient, and I get 10 equals x. And we're done. So hold up, bud, just 1 second, okay? Now, so the process here is I take the measures of the two small angles, and it's a good idea to just write them in on the diagram if you have the diagram, and set them up so that the measures of those two small angles, or the expressions that represent them, added together equal the expression or the number that represents the measure of the large angle. And from there, we're just going to solve the equation. Remember, when you're solving an equation, your goal is to get the variable all by itself, which means that you first need to get the variable term all by itself. And oftentimes to do that, you'll have variable terms on both sides, so you need to get rid of one of them. Of course, don't forget your golden rule of equations. If you get rid of something from one side, you have to get rid of it from the other side as well. All right. Good luck with those.